sıfır. Değil tabii.
Next speaker is Sh.I.Taghiyeva, and the title of her talk is Electromagnetic Radio for the N+γ star to N star states, excited nuclear states in holographic model. So please.
Thank you, Professor Shahin Mamedo. Hello, everyone. I am Shahnaz. At first time, I wanted to say that this is very good news that the relation of the Hazar University and Tamshan University relation. Then I talk about today electromagnetic radio for the nucleon, excited nucleon in holographic model. Now I speak about some information about this model and the definition of the profile function in hardware model and the definition of electromagnetic form factor in hardware ADS-QCD and electromagnetic radio for nucleon excited nucleon transitions and the results. We know that ADS-CFT correspondence is exciting discoveries in theoretical physics because this correspondence we can use this correspondence for to calculate coupling constant, form factor, and others. Recently, some others use holographic models for define electromagnetic and gravitation form factor and electromagnetic radio. And I wanted to say that especially nucleon and excited nucleon transition form factor and electromagnetic radio is calculated 0 and at finite temperature states, and we use from this holographic model hardware. We seen in one expression, the metric of a hardware model. We see from this expression that in 50 coordinate, and this coordinates extend from 0 to Zm. We can see this numerical value ultraviolet and infrared. Then now we define, we want to show that how define the profile functions in hardware ADS-QCD model. At this time, we write action as two expression, and we see from this expression Lorentz and gauge covariant derivative, and this derivative is defined three expression. Then, if we take into account this expression in to action, we define for equation of motion, and it's favorable to solve this equation in terms of Fourier components as 5 expression. And if we take into account 5 expression in 4 equation, we define 6 and 7 equations. And from this equations is this equation motion solved, and is defined 8 expressions. This expression is the profile function in nucleon in hardware model, and this expression is expressed Bessel function as 8 formula. And we see from this formula C constants. These constants were found from the normalization condition, and this is equal 9 expression. Now, I wanted to say that in general, if we want to calculate coupling constant or form factor, we must write the action at first time. Then we write Lagrangian interaction Lagrangian. Then we define the general action. We write 10 action in Hartwell model, and then 11 expression is the interaction Lagrangian. Then if we take into account 11 and 12 expression in 10 action, we define a certain expression, and this is general expression for the action. Now, we see ADCF the correspondence. Bulk and boundary theories generate functions, gauge and gravity is equivalent from the 14 expression. And other side, the vector current of nucleons, or I can say the vacuum expansion value of the nucleus vector current in the boundary QCT theory is defined as 15 expression. And we know that also positive or negative parity resonance states, electromagnetic current is defined as 16 expression. We define we take this expression with one z ADS, yes, then we, if we take into account that ADS expression in 15 expression, we define the vector current of nucleons. Then we write this 16 current, then we compare 15 and 16 expression, and we define these integral expressions. Then we define from this integral expression Dirac and Pauli form factor, or we can say electromagnetic form factor. Then we use from this electromagnetic Pauli and Dirac form factor, we define such form factors as J Q square Q square as 23, 24 expressions. Why we define this Pauli, Dirac, and then such form factors? Because we know that the electromagnetic radio is defined using this such form. I'm sorry, such form factors. And then we write here, but we don't define this. This is the definition of the electromagnetic radio general. She electric form factor is defined 25. Then we write this calculation, and then electric and magnetic form factor, the slopes of form factors in the Q square approach zero limits. The electric and magnetic charge radii are defined 31 and 32 expressions. Now, we see electromagnetic properties of the excited nucleons. Mm, First, second, and third column belong to for us. This is excited nucleon transitions, electromagnetic radio, but the less softball and experimental data. We write this results for compare. We can see from this table our results is close the softball areas, QC the model results and experimental data. And especially I wanted to say that softball and experimental data results is not calculated excited states, this basic states. And we can see from this compression, we can say that the excited electromagnetic radio differences between excited electromagnetic radio and basic electromagnetic radio between differences is very little. Thank you for your kind attention.
Any questions, please? I have some questions.
Mhm.
The Electromagnetic radii found in ADS-QCD, how much agrees with experimental data?
Oh. We say that we define electromagnetic radiation in excited nucleon, yes, but experimental data is not belong to excited states, this basic states. And we can see from this table, our result is close experimental data and software. Especially I wanted to say that electric charge is very close.
And what about a hardware model? So is the hardware model results close to experimental data or not?
Experimental data.
For these quantities, I mean electromagnetic radii.
Um, bildim. Our result is the hardware model da. Hardware model. No, this is software. Software is not for us. This is hardware. First, second, and third columns hardware. This is software by I write here Liebowski.
So any other questions? Let's thank speaker again.
Thank you.